Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing worksheet to verify cyclic quadrilateral theorem. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we are going to prepare. We are going to tell the children what is cyclic quadrilateral theorem. It connects the diagonal with the sum of the product of the two pairs of opposite side. If there is a quadrilateral which is inscribed in a circle, then the product of the diagonal is equal to sum of the product of its two pairs of opposite sides. We will show them a circle and a quadrilateral and the values of the diagonals and the product of the diagonal and the sum of the product of the two pairs of opposite side. We will tell them, and we are already told that they are equal. Now a child can come and pull and push it and then check at all the places the cyclic quadrilateral theorem holds good. Let us try to design this dynamic worksheet from scratch. For that, I have taken GeoGebra Classic 5 worksheet, geometry view, option rounding off to 2 decimal place, labeling of new points only. As usual, we will go for the heading. The heading will be cyclic quadrilateral theorem, which will be a very interesting theorem for the children to learn. Cyclic quadrilateral theorem. Now we will ask them what is cyclic quadrilateral, and we will ask them to what do you mean by diagonal, what do you mean by opposite side. Then we can declare the statement of the theorem. Now the statement of the theorem the child will understand better. Okay. Now we can draw a quadrilateral, cyclic quadrilateral for any arbitrary circle, but I am going for a different circle with integer radii, so that it will be easy for me to have a different circle and show them that the property holds good. For that I am going for this circle with center and radius, and immediately I will put here as radius as n, so that when I move this, that also will increase. Okay. Now normally as usual we will change this center as O. Well, now we will take 4 points by taking this point on the object, so that we can complete the quadrilateral A, then B, then C, then D. Well, now we'll let us press escape and then bring it outside, and then bring it outside. Let us try to complete this polygon. Touch A, touch B, touch C, touch D, and then touch E. Okay. Now let us try to tell the values of these sides. Be careful, right click, only segment is selected, otherwise the whole object will make it selected. Or go for name and value. Again touch the second one, go for name and value, touch the third one, check whether the polygon is selected over here. If the polygon is selected, please come out, then close it, then go and right click it the segment directly. Okay, now the segment is selected. Be careful, otherwise the segment may not get selected sometimes. You can select the segment from the graphic view also. Okay. Now here you should be a bit careful. Remember, the one side is A, another side is B, another side is C1, because C is reserved for the circle which you have drawn in the beginning. Okay. Well, now let us go for diagonals now. Go to the segment, draw AC and then draw this BD. Once again, escape. And come back to this AC and then right click it, go to the object property. You can ask it to show its name and value. Okay, it is showing as F to me, then it is G. Okay, good. Therefore now I can know that this is F and this is G. Good. Now I can make it little bit big so that it is visible to me. Okay, now I want to tell the children that what is actually mean by that. For that I can write it in the form of a statement which tells that the product of the diagonals is equal to sum of the product of the opposite sides, two pairs of opposite sides. Now you can show it to the children in the form of the objects also. For example, f then multiplied by the object g is equal to the sum of the opposite sides. Therefore, the bottom one is a, be careful, plus the top one is c underscore 1. Okay, I am closing it. Okay, I think it should be multiplied. Sorry, it should be multiplied. I used the wrong symbol. Okay, it should be multiplied. Okay, okay, plus. Okay, then go to the second one. It should be b and d. Therefore, from the object you take b, then again put the multiplication symbol, and then go to the object and then select d. Okay. Now remember, this is actually we are just simply telling the children that when they move it, escape. Okay, when they move it, they can understand that actually which is going on changing. Now what we are going to do is we are going to fix the exact value of it. For that, go to this view, go to this input bar. Okay, the input bar will automatically come at the bottom. Now here you have seen that up to g it is fixed. Therefore, let us go to h. We'll just have one more variable called h. This is the product of g and f. Therefore, g star f. Okay. Now you got the left hand side now. How to get the right hand side now? For the right hand side, we first have the product of a and c1. Therefore, already g f h over. Therefore, hi is equal to, we have to do the product of a star. Remember, it is c1. Therefore, c underscore 1. That's all very simple. c1 will be to be typed as c underscore 1. Therefore, I again. Then j is equal to, once again it is a product of b and d, b star d. Well, now you have to add the whatever the product you have done now. I and j to be added now. I j, k is equal to I plus j. Okay. Now let me come back to this geometry view and I will show you a graphic view and actually what happened to it. You see now this is the product h, I, j, k. You see h and k are totally equal now because this product is equal to sum of these two. But very simple. Now therefore you can come back to this ABC text and now you can show it to the children that what is the object now. Therefore the object is h. Therefore h is equal to I plus j. Therefore in this from here I plus from the object again I have to take j. Okay, you just put okay. Now a child will tell that this is the left hand side, that is the right hand side. Once again you can tell it to the children that h is equal to now already you have done the summation. GeoGebra has done the summation. It is k. Okay, equal. Now you see left hand side is equal to right hand side. Now a child can come and verify that product. They can verify their addition also. That is very well. But now it is coming. The product is coming very quickly now. Okay, now a child can pull and push it and then check whether the cyclic quadrilateral theorem holds good everywhere. Definitely it will hold good everywhere. But remember, whenever you are having that rounding off to 0 decimal place or 1 decimal place, there may be a problem in that summation and all. There may be a little bit approximations. Or I have taken up to 2 decimal places. Okay, therefore, by this particular worksheet, a child can understand what is cyclic quadrilateral theorem and they can understand what is the ratio between the product of the diagonal and the product of sum of the product of the two pairs of opposite sides. Thank you. Let us learn to